All right, good morning, guys. Good morning, Tara, Jamie, Molly, Catherine, Chris, Maria. Good morning. Hope you guys are having a good day. Hey, can I get a quick thumbs up that you guys can hear me and see me? If you can hear me and see me, give me a thumbs up in the chat box, and we will get going with this day. All right, very good. Thank you, Jamie. All right, any questions on 6.1 homework before we go on to 6.2 notes? Any questions on 6.1 homework before we go to 6.3? Or excuse me, 6.2 notes. All right, if I'm seeing none, then give me a thumbs up if you're ready to go to 6.2 notes. If you're ready to go to 6.2 notes, let's move to 6.2 notes then. Okay, cool. Cool, Tara, Catherine, Chris. Good. All right. So here is here's what we are dealing with today. We are dealing with word problems. 6.2 is all about word problems and understanding retirement accounts and interest rates and interest compounded and all that type stuff. Okay, so very quickly, let me show you something real quick. All right. And I think this can kind of maybe potentially help us understand exponential equations a little bit more. Okay. All right, I'm going to share my screen with you real quick. It's going to look a little funky for a second. And I want to share this right here with you. Okay, so here's what happens, guys. When you invest money into, let's say, a Roth IRA, which is a pre-taxed, and IRA stands for individual retirement account. Basically, it is putting money into the stock market. Okay. Now you may be saying, well, what is the stock market? The stock market is a place where you can invest in basically companies, like a company like Apple. Okay. Where you can invest X amount of dollars into a company, and then that company uses the money that you invested for newer things, better things, faster things. Okay. So you've probably heard it said before, like if you would have put, your parents, you might have heard this from your parents, that if they would have put $1,000 into Apple in 1980, that you would have, if you would have put $1,000 in 1980 into Apple, when Apple was a startup in a garage, that today that would be worth millions and millions of dollars, just putting $1,000 into it. Because obviously the evaluation for Apple is $1 trillion. So your $1,000, which you initially invested, would have grown so much. And that's what we call exponential growth. And since we're talking about the exponential function, you need to know just a little bit about that. So here's a good example for you all that is a phenomenal example of investment and exponential growth, okay? And here's the thing with exponential growth. It's all about time, okay? Everything depends on time. So if I'm looking at this right here, we see this is Ben over here. Ben, at the age of 19, starts investing $2,000 a year into an account, what we would know as a Roth IRA. This Roth IRA grows at 12% per year. Okay? So, for instance, if I had on my calculator 2,000 and I multiply it times 0.12, I get $240. So, since he put 2,000 in, his year-end total, what he now has after his interest has been paid, after his money has grown, is now $2,240. Okay? And each year he continues to invest $2,000. Now, as you see, 1, 2, 3, 4, 5, 6, 7, 8. So he invested $16,000 from the age of 19 to 26, and even at investing $16,000, here's what he's made: $27,551. So if you were to subtract that $27,551 from what he has put in, he's made a total of $11,000 in 1, 2, 3, 4, 5, 6, 7, 8 years. Now that's not a lot of money in turn. $11,000 is not a lot of money over 8 years, because the average income for Grove City is $68,000 a year. So you make more, you make a ton of money just by working. So $11,000 doesn't seem to be that much over 8 years. But now check out my guy Arthur. Arthur didn't start investing until he was 27 years old. Okay? Now, Ben stops investing or basically 26, 27 years old. But Ben, because he's already accumulated this $27,000, if the stock market continues in the route at which it's going, Dave Ramsey, who's a financial guru, says that the stock market on average from maybe 60 to 2015 grows at a rate of about 12%. If that continues, that trend continues, look, his money is making money off of his money. So as I scroll down here, watch how Ben's money, keep in mind he just invested $16,000, but because he did it early, and because we hadn't had a stock market crash, and we haven't had a coronavirus crash, we haven't had any of that, watch how his money just begins to exponentially grow. Going all the way down here to when he is 65 years old. Okay? So that is 46 years later. Because he invested so early, his $16,000 that he invested based on this model of growing at 12% each year, his $16,000 he invested grew to $2.2 million. So when he's 65 years old, he'll be able to basically live on that $2.2 million. And trust me, you can live on $2.2 million. But now watch our guy over here, Arthur. Arthur started investing late. So Arthur started investing at the age of 27, and he put $2,000 in there a year. And as you see, these numbers right here are the same, going up. Each one, those are the same. And he's at 27. I messed that up. Let me see if I can go back to that. Let me zoom out. Oh, man. There we go. There we go. Sorry about that. So going back to this, as you see, at the end of 8 years, he was at 27, and at the end of 8 years, he was at 27,551. So it's growing at the same rate. But watch this, because he did it so much earlier, Arthur actually continues to invest money. And for 38 years, he invests $2,000 a year, bringing his total amount to $76,000. So he put in $70,000 more than our guy over here did, but he only ends up with $1.5 million. So he invested $70,000 more and is almost $1 million off of this guy right here. And the key difference here, guys, is that this guy over here, Ben, started investing at a very young age. And that is a very valuable lesson. If you don't learn any math from me, know this lesson right here, that your money can grow itself. And that's what interest is. Interest is basically your money earning. Basically, you're earning money off of your own money. Okay. Okay. So, what we're going to kind of talk about today is compound interest. That's really what we're looking at. And let me move this out of our way now. And with compound interest, okay, let's write that word down, compound interest. And what compound interest is, guys, there's kind of a, basically, it is what it literally is. Compound means to basically to build something. It's basically, I'll define it as this. When interest is paid monthly, the interest earned after the first month becomes part of the new principal. Now, principal is just the total amount. And this process just keeps going. So, in my words, compound interest is interest earned. You make interest, you get money, interest earned on interest earned. That would be my definition of compound interest. It's just simply interest earned on interest earned. So the money that the bank gives you for investing, you earn money on top of what you earn from them. So that's what compound interest is. Now, different banks do different things, guys. Different banks do different things. Some banks compound interest annually. Annually would mean that they take your total amount of money that you have and they compound it one time and say, we're going to pay you X% this one time. And that's the interest you earn on that year. So, annually would just simply be once a year. One time per year. If it is semi-annual, I don't know why I'm lagging so bad. That would be 2 times per year. If it's quarterly, that's 4 times a year. And if it's monthly, that's 12 times a year. Okay. So there is a formula that will allow us to calculate how much people make. And that formula is this right here. It's called the compound interest formula. And here's what it is. A, the amount you make, is equal to the principal times 1 plus the rate over n times n raised to the t power. Where A is the amount, rocket. A is the amount, P is the principal, R is the rate, N is the compounds, how many times it's compounded, and T is time in years. Okay? So, that's what compound interest is. And basically, compound interest is when you put money into an account and you basically earn interest on it. And compounded interest is just like when you make this amount of money and then you make more money based on the money that you've already gotten from the bank. So your money grows each time. And the example of the two columns is a perfect example because he wasn't investing any more money, but he was still earning money, and that's on compound interest. He's earning money on his money earned. Okay, so let's jump into these problems. Give me a thumbs up if you're ready to go with the problems. Cool, Tara. Cool, Jamie. Good. Okay, here we go. So, guys, this is actually, once you have the formula, you're good. It's just plug in from there. And then this is just, you're going to use your calculator to find these. So it should be pretty simple. All right. So Imani invests $8,554 in a retirement account with a fixed annual interest rate of 6% compounded 2 times per year. What will the account balance be after 18 years? Okay. So always write our formula down. Amount is equal to the principal times 1 plus R over N NT. So our amount is going to be equal to our principal. Remember, principal is what she initially invests, what her amount is. She put $8,554 in. Then we say that times 1 plus the rate. R stands for rate. But you always want your rate. Notice her rate is 6%. You always want to write your rate as a decimal. So 6% as a decimal. If y'all remember, you go back twice. 1, 2. And that would be equal to 0.06. So plus 0.06 over how many times it's compounded, which is 2 times per year. So over 2. And then raised to 2 times 2 comes from the compound. N is the same. And then T is the number of years, 18. So from there, we just get our calculator, guys, and we just type it directly in. 8554 times 1 plus, now watch this, I'm going to hit alpha y equals to get my fraction button. If you don't, then you can just write it as a normal fraction there if you don't have that fraction button. And the number is 0.06 over 2, and then raised to the 2 times 18 power. We hit enter. And we're going to round everything to the nearest hundredth since this is money. So she will have a total amount of $24,791.87. Any questions? Y'all have any questions or any questions at all of that? Or are you good? Give me a thumbs up if that kind of makes sense. Very good. Cool, Terry. Good, Adam. Good, Maria. Good, Catherine. All right. So then we just jump over here to the next one and start the same way. So start with our formula. A is equal to P times 1 plus R over N times N to the T power. Sorry about that. I had to help land it. So A equals P times the quantity of 1 plus R over N raised to the N over T, and then just type everything in. A is equal to 5,952 times 1 plus, now remember, here's our percent, but we need to write it as a decimal, so that's just 0.07 over the N. It's compounded twice a year, so that's 2 all over 2 times 5. The NT is T is time. Same thing here, guys. We're just going to get our calculator out. And we're just going to type it straight in. 5,952 times 1 plus, I'm going to put a fraction in, 0.07 over 2, and all that raised to the 2 times 5 or times 2 times 5 or just 10 power. I hit enter. I get $8,395.88. $8,395.88. Okay, look at number 3. Here we go. Stephanie invests $7,150 in a retirement account with a fixed interest rate of 5% compounded 6 times per year. So guys, here's what happened. She invests $7,150 in, and then it's 6 times per year, so that's every 2 months. Every 2 months, they pay her 5% interest on the $7,150. Okay? And then after another 2 months, whatever amount that was, now they pay another 5%. Every 2 months, they pay an additional 5% on the amount that's in there. Okay? So when it was done twice a year, up here like on problem 1, when it's done twice a year, she put that amount in. And then so let's say she put that in January. Then at the end of June, beginning of July, they gave her 6% of whatever that amount is. Okay? And then she got a brand new principal, right? Then at the end of December, they gave her another 6% of whatever that new amount was. So that's how your money makes money. And of course, the bank wants your money because that allows them to deal with clients and customers more. All right. So just making sure you kind of understand that whole compound interest and what it means for something to be compounded 6 times per year. Okay, so here we go. A is equal to P times 1 plus R over N to the NT power. So my principal, 7,150 times 1 plus the rate of 0.05 over 6 times 19. 19s are years. 6 is how many times it's compounded. So we just type it in. 7150 times 1 plus, set up a fraction, 0.05 over 6 raised to the 6 times 19 power. 18,415 and 19 cents. 18,415.19 cents. Don't have to worry about 4. I think you all can kind of see how it's working through those first 3. Okay. So then let's go to the last 4 problems on our notes. Notice this says, Mike invests $6,676 $76 in a savings account with a fixed annual interest rate of 6%, compounded continuously. So, if you think about it, the more compound you would have in a year that an account will give you, the better it is for you, right? If it's constantly compounding, like if it compounds 12 times a year, that's really good because that means every month you're getting more money. So then basically banks just started saying, you know what? We will compound your money continuously. Okay? We will compound it all the time, 24/7, 365 days. We will constantly compound your money. Now that sounds like, oh man, if they're constantly compounding your money, then that means you're going to get a lot of money. Well, yes, while at the same time, you would have to invest a ton of money for it to actually grow that much. And if something is compounding continuously, I doubt they're going to give you that high of an interest rate where you're going to make a lot of money. So it's kind of like one of those things. If it compounds a lot, then your interest rate is lower. If it compounds less, then your interest rate could be higher. All right, but there is this thing that this is a different formula than our compound interest formula. This is just a little bit different than that. And what this is, and what this is this is the continuously compound interest formula. So I'm going to write that down. Continuous or continuously, compound interest formula. And here's what it is. A equals P, your principal, and then the letter E, and then R to the T. Now, this is the first time we've seen E in Algebra 2, okay? And this E here is an irrational number. It's an irrational number. Very similar to pi. Its value is 2.71828, 1828, 45, 90, 45. And it keeps going from there, guys. So it's just like pi. It goes on forever. And it's referred to as, most of the time we just call it E, but it's also what we would call Euler's number. Okay? And he was the one that kind of really found out about all this information. And here's what E basically means. Again, I could kind of show you the math behind it, but it can get pretty crazy. But basically this E is the maximum amount you could make when something is compounded continuously. So if you had $1 and then you doubled it every hour, or you doubled it every day or every hour or every minute or every second, the maximum you would make from that dollar is this E, 2.7182182. So E is what we use for continuously compounded interest formula. Okay, so it's a little bit different equation, but possibly a little bit easier. So you just need to know these two equations today and know when it says, what is it, compound continuously, I use this. If it's compounded a certain number of times, I use my compound interest formula. And I actually misspoke the other day. I said that this next lesson would be a little bit longer, but it's actually the last lesson on Monday. My computer just made like the weirdest sound in the world. No clue what happened. Okay. But it's actually the lesson on Monday that'll be a little bit longer. So I misspoke the other day on that. So, but then that's your last lesson. Then we have to do the study guide. Then we got to do the chapter 6 test, and then the final. So we're almost done, guys. All right, so here we go. We're just gonna type this in. A equals PE to the RT power. Okay, so here's what we're dealing with. A is equal to our principal, 6,676, times E, the rate, always write it as a decimal, 0.6, times 6 years. Now, E on your calculator, guys, will be the division sign. You got to hit second and then the division sign. Everybody see the E there? Right above the division sign, so you'd have to hit second and then hit E. So I'm going to come up here to my calculator and I'm going to type this in. 6,676 second E, and then raised to 0.06 times 6. I hit enter, and I get 9,568, and that 7 would round the 0 up to 1. So 9,568.91. Right. Shh. All right, give me a thumbs up on that, if that makes sense. Okay. All right. I apologize if there's some technical issues today. I'm not sure what's the deal. All right. So number 6, last one. A equals PE to the RT. A is then equal to 3,858. E, we know we use this because it's compounded continuously. Then E, and then R is the rate, which is 0.03 times 19. I type that into my calculator. 3,858 second E raised to the 0.03 times 19. I get 6,821.97. 6,821.97. All right. I think that will do it for 6.2 note. Are you good, guys? Good from there? Or do you want to see me work the other two? I think they're pretty straightforward. Do you want to see me work the other two, or are you guys good from there? All right, if you guys are good from there, I don't know. It's saying I have low output, video output is low, so I'm not sure what's happening. I'm not sure if I'm using too much internet in the other parts of my house. So we'll just conclude there. If you guys are good, you guys are free to be dismissed, and I look forward to seeing you guys on Monday. Okay, look forward to seeing you guys on Monday. And I will get the grade book updated probably today. So you'll have that. You'll see your updated grades for all of that. So all the homework you guys have turned in. So, hey, you guys have a good day. Sorry for the technical issue today. Hopefully it got through a little bit though. So, hey, have a good day. I'll be here for a second. If anybody needs to type something in the chat box, I'll be here. Thanks, guys.